Welcome back, students. So this is the Q&A session 15 from the playlist of friction, and the topic for the today's session is the calculation of the maximum length of the hanging chain. So with regards to this topic, I have taken one question which is written on this board. So this question was asked in the CBSE All India Pre-Medical Test a few years back, and the question is: a uniform chain is lying on a table. The coefficient of friction between the table surface and the chain is 0.25. So the maximum length of the chain that can hang over the edge of the table is. So there are four options here, and we have to find the correct one. So in order to save the time, I have already drawn one very simple diagram here. So this is the chain which is lying on this table. This is the table, and the coefficient of friction between this table surface and this chain is 0.25. So we have to calculate the maximum length of the chain which can hang over this edge of this table. So here, this is a uniform chain. So in this question, let us consider the mass of the chain. Mass of the chain as, let us say it is capital M, and let us consider the length of the chain. As capital L. Now since it is a uniform chain, therefore the mass per unit length will be equal to M divided by L. Now let us consider the hanging part of the chain, the length of the hanging part of the chain, length of the hanging part of the chain. Let us consider this as X. So if X is the hanging part of this chain, then the mass of the hanging part of the chain, will be equal to M upon L, that is the mass per unit length, into X. Now, this chain will not fall down, or it will keep hanging over the edge of this table only when the weight of this hanging part of this chain is balanced by the force of the friction. Now this chain has a tendency to move downward. Okay, na? So because of this, because this chain has a tendency to move downward or fall down in this direction, therefore the force of friction, let us say, I am just denoting this as Fs. So this force of friction will be acting in the direction as indicated by this arrow. Now if the force of the friction is able to balance the weight of this hanging part of the chain, then in that case this chain will not fall down. So the force of the friction, now this force of the friction is basically the maximum value of the force of friction which can be generated between the surface of between this table surface and the chain, and that is called the limiting friction. So the maximum value of the force of the friction which can be generated between this table surface and the chain, this will be equal to mu mg. Now here the m is the mass of the chain which is lying on the surface of the table. So this will be equal to mu m by L into, now this is the mass per unit length. Now the length of this part of the chain will be equal to L minus X if the hanging part of the chain is equal to X, because the length of the chain which we have considered here in this question is L. So the length of the chain which is lying on the table will be equal to L minus X if the hanging part of the chain is equal to X. And this is so the force of the friction will be equal to mu m is equal to m by L into L minus X into G. So this is the force of the friction. And now if the this force of the friction is able to balance the weight of this hanging part of the chain, then this chain will not fall down. So in this case, mu m upon L minus x into G, this should be equal to the weight of the hanging part of the chain. Now weight will is equal to mass into this acceleration due to gravity. So this will be equal to m by L into x into G. So this is the equation which we have got, and by solving this equation we will be able to find the value of x in terms of L. And here we have to find the maximum length of the chain which can hang over the edge of the table in percentage. So now here I am just I will be now from this equation we are getting this, that this m and m will get cancelled out, this L and L will also get cancelled out, and this G and G will also get cancelled out. So finally what we are left with, that is mu L minus x, this will be equal to x. So it implies that now mu is equal to 0.25 and this will be equal to L minus x, and this is equal to x. Now 0.25 can be, I am just writing it as 1 by 4, so this will be equal to L minus x will be equal to 4x, or it's simply we can say that 5x is equal to L, or this x will be equal to L by 5. So now we have to find the maximum length of the chain in percentage. So the percentage of or we can say that length of the hanging part of the chain. This will be equal to, or you can say the maximum length of the hanging part of the chain which can hang over the edge of the table. This will be equal to L upon 5 divided by the original length, which was L, into 100. So if I solve this equation, I will be getting the value as 1 by 5 into 100, and this is equal to 20%. So the maximum length of the chain which can hang over the edge of the table is equal to 20%. So the correct option is A. So in this question, we have to use the concept that this weight of this hanging part of the chain should be balanced by the force of the friction in order to prevent it from falling down. So thank you very much for joining this session. In the next session, we will be coming up with a different topic, and the topic will remain the same, that is friction. So till then, have a nice day. Bye.